Welcome to the Insightful Professor. Today's topic is missing information. In this video, we will introduce a concept of the null value. This is a special value used in relational databases to indicate that some real value is missing. The presence of a null value in a table's column, however, does not indicate the reason the real value is missing. It only serves as a placeholder to indicate missing information. The presence of null values in a table is very common, so it's important to understand how this value is treated by SQL statements. That's the whole point of the current video. We again apply the operations that we'll demonstrate to a single table. Most of the examples will use a new table that we've not yet seen. This one is created purposely just to demonstrate the behavior of the null value. The name of this table is NULL tab. Before we start, we have to make a little confession here. We were faced with the familiar chicken and the egg problem. Someone asks this perplexing question: which came first, the chicken or the egg? Well, the current topic we have is the null value and missing information. But to be complete, we want to demonstrate its behavior all within this video, but there are other aspects of SQL that we've not yet introduced to you. So we're going to jump ahead and show you some examples from things that we will formally discuss in a later video. So our apologies if there's any confusion as we present this, but hopefully you'll get the point of what we're trying to do with the missing information and concentrate on that, and then be able to understand when you see this topic presented slightly a little bit later with another topic. So again, we apologize if there's any confusion there, but again, chicken and the egg is a perplexing problem to address. Okay, let's start off by describing what is the null value. Well, there are times when certain information might not yet be known about whatever it is, what the entity is that we're going to record within the database. Say, for example, we were so excited about hiring you as a new employee. Obviously, we have your name, we have things like your social security number or something of that sort. But maybe there was other data that we'd like to store about our employees, but we didn't have the time to get it from you. So, for example, maybe what is your favorite color? So maybe that's critical HR type of information. So what we wanted to do was get a record of your existence within the organization recorded, but we didn't have all the pieces filled in. So in that case, when it comes to the column that says favorite color of this employee, we can't say it's blue, it's orange. What we have to say is, well, we don't know what it is. It's unknown at the time. It's not that the individual doesn't have a favorite color, it's just that it's not known. That's one idea of where the information could be missing. Another situation where information could be missing is it does not simply apply. So, for example, if we were talking about a database created with a table that records information about students in a local school system, maybe it's a high school. Some of the students in the high school may not yet be old enough to legally obtain a driver's license. So therefore, if we recorded as one of the attributes or one of the columns the date that the student acquired their driver's license, for some students, null may very well be an appropriate answer. Now, in that case, it's not so much that we don't know when it is, but because the student is of too young an age to actually earn or acquire a driver's license legally, then it's simply a case that null in that situation represents the value is missing for a different reason. It's unknown or not applied. In this case, it's not applied. It's not applicable. Okay, so null is not the same as a 0 for a numeric field, nor is it the same as a blank for a character field. Now, what we're going to do is demonstrate several queries on this topic to illustrate how nulls are treated, because it changes the semantics. some of the query meanings are going to be a little bit different when we look at the results. And it also has an effect on the syntax of SQL as well. So we want to bring that to your attention. I've yet to see a real-world database that completely prevents nulls from being present. So therefore, I think this is an important topic. Now, we're going to start off with calculating, but before we do that, let's show you the actual table called null tab. I have this table created in both my Oracle and my SQL Server databases. So I'm going to simply run a query here that shows you the content of the table. We're going to say select asterisk from null tab. When we do this in Oracle, it looks kind of like a piece of Swiss cheese, you know, that cheese that has all the holes in it. And that's what we have here. There's a big hole here, and there's holes all over the place. Those holes don't contain a value of 0. Otherwise, 0 is a real-world value. It's a known value that would be reflected in the output. Those aren't blanks because clearly these are numeric columns. So they're not spaces in there either. But what happens is, by default, this front-end tool, called SQL Plus, renders as output an empty string whenever it has encountered a null value and is displaying it. So Oracle has a little toggle we can look at. There's a parameter here called null, and I'll show null to see what its setting is. And right now it's quote, quote, which represents an empty string, which explains why you've got this blank display here. We could set null to some other value. For example, I'll set it to a couple of question marks, and then I'll run my query again and show you what happens. Now, wherever a null is encountered, the front end will render it using this special symbol. So you can see that there are nulls all over the place. Here's the width of column A, and you can see that we've got 10, 30, 160. These are known values. And then here's that symbol that I told the system to use, a sequence of a few question marks. So you can see now, visually, this is emphasizing the fact that row 4, row 5, they have a null value in col A. This can get a little messy, so rather than just have the front-end tool show it, I'm going to suppress that by going back and saying set null, and I'll use quote, quote. Then we'll run the query again, and we're back to our slice of Swiss cheese. So anyway, I wanted to show you how to accomplish that if you're working with Oracle. Now, let's go to SQL Server for a moment. SQL Server is kind of nice in this regard, because when we execute the query that says select from null tab, notice what SQL Server does. Wherever there is a null value, it puts out this sequence of characters, NULL. That doesn't mean it's actually a character string, 4 consecutive letters stored in that field. That's not possible, once again, because col A is numeric. However, it's a nice visual aid or visual cue to emphasize the fact that there is a null in that particular row-column intersection. So different front-end tools have different ways of doing this, but be aware that when nulls exist, we need some type of cue that that is a null value when we're displaying it. And we're going to look at ways that we can manipulate the nulls within our SQL statements to render the result with something else that might be more meaningful, more purposeful. But again, if you simply encounter a null and then have it presented to the screen, there are different ways that it might be rendered. Okay, so that's the background on that. Go back in and take a look at the query that is of interest to us here to get the ball rolling. When we do calculations, this is one of the areas where null values kind of cause some problems. They make some waves, if you will. We say when a calculation involves at least one null value, which again we could say represents an I don't know situation, an unknown value, the result of the calculation will be unknown. So we'll see this as we look at the arithmetic expressions here. And what happens is null, if it represents unknown, that's what will appear in the output. So you had a little exposure very briefly to the null tab table. We're going to go and take a closer look and run this query. We're going to select what's stored in PKEY, what is stored in col A, what is stored in col B. Simply retrieve the values as they exist in the database. But then comes the fun part. We're going to do some arithmetic. We're going to take what's in column A and add to it what's in column B. And we're going to take what's in column A and subtract from it what is in column B. And these are the queries that we want to give some close attention to see how nulls are treated within the database. I'm going to do probably most, if not all, of the queries with Oracle, simply because, as you can see here, it displays a little bit better. It's all on one screen. I don't have to scroll. But the results are going to be similar in the two databases. So I'm going to select PKEY, col A, col B, and that's not going to be a surprise. What we're going to see is simply the same stuff here. But what I'm going to do next is I'm going to take what's in col A and add to it what's in col B. Now, from the video where we talked about expressions, you should be familiar with the idea of taking the value in one column, numeric column, taking the value from another numeric column, and doing arithmetic like add, subtract, multiply, divide. And that's all we're doing here. But the trick is going to be what is going to happen when we look at the null values. Well, let's take col A and add to it the value in col B. So 10 plus 20 gives us 30. 30 plus 30 is one value here shown as 60. Then we have 160 plus an unknown amount. Let's suppose I ask you the question. I have 160 items on the table, and I'm going to add to it some additional items, but I'm not going to tell you how many. It's unknown how many I'll add. What's the result? Well, logically, it makes sense. We don't know, because we don't know how many items were added to the 160. And likewise, if you go the other way, unknown, and you add a known amount, you don't know what you've got. Furthermore, suppose you had two unknown amounts, as shown in row 5. What happens when you say, let's add an unknown amount to another unknown amount? Well, again, not surprising, what you'll get is unknown or null. And again, if we had the visual cue here, we would see some symbol, or if we were doing it with SQL Server, we would see NULL on the screen to emphasize the fact that what we had was the idea of a null value in the result. Okay, this is informally what I refer to as horizontal arithmetic, because we're taking a value, col A, for example, and taking another value, col B, from the same row and adding them together, going across the horizon, taking a value from one row and a value from another row. Now, this is where I kind of jumped the gun, perhaps. This is where the chicken and the egg problem arose. What I'm looking at is I'm now doing something which I might informally call vertical arithmetic. There's another video that will describe all of these functions in great detail, but what I wanted to do was I wanted to show you both horizontal and vertical. When you apply an aggregate function, and that's what we have here, these are aggregate functions, sum, max, min, average. What happens is, if a column is passed into an aggregate function and the column contains a null value for a particular row, that null value does not participate. It does not contribute to the value of the sum or the value of the average. The nulls are effectively ignored in this situation. So hopefully that's sufficient to satisfy your curiosity about these particular queries with these aggregate functions for the moment. So let's go and take a quick peek at this, and we'll go ahead and give this one a try. Just a quick refresher of what's in the table. Select asterisk from null tab. And what we're going to do is, instead of going across to do the horizontal type of arithmetic, we're now going to go vertically and look at all the values in the column. If the behavior was identical, we would say 10 plus 30 is 40, 40 plus 160 is 200, and then we encounter a null, all of a sudden it becomes null. But what we're going to see is in this vertical type of arithmetic, which is achieved by using these aggregate functions, the behavior is different. It's a different treatment of null values. So let's take the sum of col A, and we'll take the average of col A, two columns functions where we're going to be doing the arithmetic type of operations. Then, interesting enough, we'll say what is the largest value in the column, and then what is the smallest value in the column. Now, prior to running this, what we'll do is, let's say, if you look at all the values in the column, what's the highest? And if you immediately say 160, that seems logical because that's the one that you see as the largest. But what is this one here, the one that you don't know? Couldn't that possibly be larger than 160 if you knew what it was? And likewise for the min, couldn't that possibly be smaller than the 10 if you knew what it was? So the point here is that if we keep the nulls in there and we say, well, 160 is the largest and null was also considered for evaluation, we might not be accurate. So the idea is even for the max and the min where you're looking at the largest and smallest, just ignore the nulls. So let's fire this up. Okay, now let's take a look at what's in column A and look carefully at the sum. The sum is 240. If you look at these 5 values that are not null and add those up, you get the 240. What is the average? Well, we come up with 240 as the sum, and we divide by the number of non-null values. So if you take the 240 and you divide that by 5, because we have 5 non-null values, you get the 48. And again, as we emphasized, ignoring the nulls, we see 160 is the largest or the max, and 10 is the smallest or the min. So it's not that difficult, but the point is there's a very distinct difference between this kind of horizontal arithmetic, where if a single null participates, the result is null. And this vertical arithmetic, which is what the aggregate functions do, nulls just don't play the game. They sit on the bench and watch. So you've got to keep that in mind, kind of the direction of the activity. Next, we look at another aggregate function, and this is the count function. What count does is it tells you how many rows are in a table when you specify count asterisk, or how many rows are in your result set when you simply say count asterisk. Count and putting the name of the column will count the number of values in that column that are not null. So, let's take a look at how this works and see what nulls do to affect its behavior. So let's say we go give me count of column A and give me the count of asterisk from null tab. Count column A gives us 11, which is the number of rows that we saw in the feedback message. Count col A says there are 5 values in column A that are not null. Potentially there could be 11, but only 5 of them are not null. The difference here is the remaining values are all null. Tricky, but it's very important to understand this. Okay, so we're pretty much done now with the aggregate functions. So hopefully that wasn't too distracting. Well, let's go back and look now at a little bit more. Let's talk about how nulls work with comparison. We had said that when you're looking at the nulls and you're doing the arithmetic, well, the null is an unknown, so clearly it's going to somehow be treated differently when you compare it with a known value. You can't say that they're the same. But what happens when you try to compare 2 nulls with one another? Like suppose I told you I have $10 in my left pocket and I have $10 in my right pocket. Now, if I ask you, do I have the same amount of money in each pocket? Are the 2 values equal? Well, you know what both values are, so you can make the determination. 10 is equal to 10. If in another case I said I had $10 in my left and 20 in my right, do I have an equal amount in each pocket? And again, you can draw the conclusion, no, they're not equal. But suppose you don't know what the values are, and I say I have an unknown quantity of money in my left pocket, and I have an unknown quantity in my right pocket. When you knew that they were both 10, you say, oh, it's the same, they're equal. Well, now you know that they're both null or unknown. The question is this unknown equal to the other unknown? Well, you don't know. That's the problem with nulls. And it turns out if you try to do a comparison of this sort, it might be a little surprising what happens. Let's select from Null tab. And here's a case where column A and column B both have null, and several other rows where column A and column B, again, both have rows. So if we say let's select all the rows from Null tab where the value in column A is equal to the value in column B, there's only one row that the system says definitely satisfies that condition. Even though we have an unknown, and the value for this unknown and the value for null is rendered the same way on the screen, the two instances are not the same. Here the two instances of 30 they're rendered the same way, but they also happen to be the same value. So null is really a funny animal. It's kind of tricky that you have to be aware of it. The general rule here is if you're doing a head-to-head comparison, as we're doing here, is one null equal to another null, the system is always going to say, I'm not going to say no, but what it says is, I don't know. Kind of funny stuff. Now, let's compare a known value, in this case a department ID of theology, to an unknown value. I'm going to take a quick look at the staff table so we can make sense of this query. If we select from the staff table, we have an interesting individual here. Good old Da Vinci has a department ID which is actually the null value. We don't know what his department is. So this is where the fun stuff starts to come in with our current queries. If I say, let's count the number of rows in the staff table that satisfy the condition of department equal to theology. And I guess I was wrong. Here's another instance of the aggregate function. But hopefully you're comfortable with what the count asterisk does. Just counts the number of rows. So let's count the number of rows in the staff table where the department is equal to theology. And we get 4. And that looks good. So we got 1, 2, 3, 4. Someone else takes a slightly different approach and asks this question. How many rows are there in the staff table where the department is not equal to theology? Well, if we look at it, we say, well, there's 1, there's 2, there's 3, there's 4, and then we get this guy here. Now, what we're doing as we come to that row, we're comparing null to see if it's not equal to theology. When we did this comparison up here, we also compared null. Well, because we had to process the Da Vinci row, we also compared null from Da Vinci to see if it was equal to theology. And the system said, well, I can't say that it is. So that's why Da Vinci's row was not counted. And likewise here, when we encounter Da Vinci's row, we have null, and we're saying, is it not equal to theology? And when we run this, we again get 4, because the system can't say that the null is not equal to theology. So it can't conclude that it's equal to the known value, nor can it conclude that it's not equal to that known value. And if you simply put these two counts together to form a sum, you would say, well, I got 4 people who don't work in theology plus 4 people who do, therefore I must have 8 employees. But if you simply count up all of your employees and don't put any kind of a test, you find out 9. But of course, everyone knows 4 plus 4 is 9, right? Well, when you're dealing with nulls, that can happen. Tricky, tricky stuff. Now, take a quick look at what we have here, because we just gave you the idea that when you're dealing with nulls and you're comparing nulls with known values, or you're even comparing nulls against other nulls, the nulls effectively cannot be determined to be the same as any of these other values. But let's consider the behavior of the good old distinct keyword. What does distinct do? Distinct says remove duplicate. There's another function here that we'll take a look at with the count in just a moment as well. But let's go to one that you should be comfortable with. Let's select the values in column A from Null tab. And you'll see there are 11 rows. Here are the values. And again, there are several nulls in there. Now let's modify the query and tell the system to remove the duplicates from the output for column A. So it's almost the same query except we want duplicate removal. Now notice what we have. We have 30 occurring once where it had occurred multiple times before, 10 occurring once where it had occurred multiple times, and then we have also a value of 160. But notice we had several instances of null, but the reflection here is that null appears only once. Just to confirm that behavior for you, I'm going to show you that there is only one indication of null. So now you're probably getting a real warm and fuzzy feeling inside. If I compare two nulls directly in the where clause, the system is not going to tell me if they're the same. But if I kind of behind the scenes compare two nulls by saying keep all the things that have the same value as only one instance in the output, that is remove duplicates, which means, well, this thing is equal to this, then the treatment's a little different. It says one null is equal to another null when you're doing things like duplicate removal. Now, it might be a good idea to pause the video because your head might be spinning at this point, because this is very, very awkward and perhaps a bit confusing. Okay, but this is the treatment. This is why I have a special video focused or dedicated on null values and missing information, because this is kind of a controversial topic within relational database, but you have to be aware of how it works. It's not going to go away. Unless you're an ostrich and you can bury your head in the sand, then you're going to have to deal with this. Now, this other one is a variation on an aggregate function. We're going to count asterisk, count the number of rows, but something we've not yet talked about, but you'll see in a future video, is the concept of grouping. All this is really doing is taking all of the rows that have the same value in this column, col A, bundling them together. It's kind of like what's going on here. If it's the same value, show it only once with distinct. If it's the same value or the values are equal, bundle it into one pile. And here again is the funny situation. All of the nulls are considered to be equal or the same when we do grouping. Again, really kind of quirky, but something you just can't avoid. And I don't think we need to see null anymore, so I'm just going to reset that to an empty string. Okay, when you're dealing with predicates, if you've gone through the complex retrieval conditions video, you saw that we can connect predicates with Boolean operators or connectors such as and or. And we also have the Boolean operator of not. So when we're dealing with these situations, we recognize that each individual or simple predicate can itself evaluate to either true or false. And then to combine two predicates with and, both must be true for the complex predicate, the complex condition to evaluate to true, or with or, either one or both could be true, and the result of the complex predicate will be true. If we have not, well, if it's true and we negate it by applying not, it becomes false. If it's false and we negate it by applying not, it becomes true, a simple toggle. However, from what we've seen thus far, there's actually a third outcome to evaluating a predicate or Boolean expression. What we have is the expression could be true. Theology is equal to theology. The expression could be false. Theology is equal to philosophy. That's false. But what about theology equal to null. That doesn't evaluate to true. It doesn't evaluate to false. It evaluates to unknown or null. So now, instead of a simple two-value logic based upon true and false, we have to deal with a three-value logic where we have true, false, and unknown or null, our third possibility. And now our truth tables, in terms of how to understand a complex predicate, have to be adjusted, or how to understand the application of a Boolean operator. So what we have is, in the case of not, if something is true and we negate it, then it evaluates to false. If it's false and we negate it, it evaluates to true. If it's unknown or null and we negate it, we still don't know what it is, so it continues to be unknown. Similarly, with and, if you have one thing that's true and the second is true, then the result is true. But if any one of them, or either one of them, is false, it doesn't matter what the other is, it's false. But suppose one of them is unknown and the other is true, you don't know what you got. And suppose they're both unknown, you don't know what you've got. And similarly with false, if one of them is true, it doesn't matter what the other is because we only need one. But if one is unknown and the other is false, we don't know for certain that the whole expression is false. And similarly, if they're both unknown, we don't know. Really nasty stuff. And here's a little example where we bring it together, where we have two simple predicates combined with or, and these predicates are going to evaluate in different ways. Let's go ahead and demonstrate how this one works. Select all of the rows from Null tab, where the value in column A is equal to the value in column B. Let's just scroll up for a moment, just so we can refresh our memory here. Column A equal to column B. Remember, there's only the one. The second condition is going to be column A greater than column C. So you can see there are three situations here where A is greater than C, and two situations here. But when I look at this one for A and I compare it to C, is null greater than 10? We don't know. So that expression could evaluate to null. The other one where A is equal to B, here's 160, and we compare it to null. Is that equal? We don't know. So the point here is that as we run this query with these two simple predicates and combine them, that they're not necessarily both going to be true, both going to be false, but we'll have a situation where one could be true and one's unknown, or one could be false and one's unknown. And that's where that truth table comes into play. Oh, I said and. I'm sorry, it was supposed to be or. Okay. There we go. That makes a little bit more sense to run the query that we're talking about. I'm just seeing if you're paying attention. Glad you caught that. Okay, that's the behavior. So, I'm not sure you're getting really comfortable with this, but hopefully at least you're grasping the concept and recognizing the importance of all of this. And we've got a few more. Let's suppose we're faced with another situation. Suppose you are working at IBM and you're writing the database, or you're working at Microsoft and you're writing the SQL Server database, or Oracle Corporation. You've got to deal with another situation here. Here, we're not applying any functions, we're not evaluating any expressions, but we're selecting a column, col A, which can contain null values, and we are given the instruction to show all of the values in column A, because notice there's no where clause, no filter. So all of the rows will come up, hence all of the values from column A must be displayed. Then we're told on top of that, sort the result, present them all in high to low or low to high, whatever. In this case, it's low to high, it's ascending. Where are you going to display your null values once you get them? If you put them on the low end, what that means is you're kind of implying that all the nulls are less than all the known values. If you put them on the other end, then you're suggesting the opposite. So you put them on the high end, you're suggesting they're larger than everything else. But you have to put them somewhere. So at least in this case, we can't fault the vendor's decision as to where to put it, as long as they do it consistently. They don't just randomly display the nulls in the output, but they always put them on the low end or always put them on the high end. Then we can kind of sympathize with the situation that they're in. Let's go to Oracle and see what happens. PKEY col A from null tab, order by col A. And what Oracle does is by default, it puts all of the values that are null at the high end. Again, they're not saying that they think nulls are bigger than everything else. It says, I got to put them somewhere, so arbitrarily they chose to put them on the high end. I am going to do one more example with SQL Server. Let's go back and show you what happens here, because this is rather instructive. Same exact query, but now when I execute this, SQL Server is a little different. They put all the null values on the low end, the exact opposite of Oracle. Well, I guess you can't fault them for making a decision to put them on the low end versus Oracle putting them on the high end, but it would be nice if the vendors talked to one another and did something consistent here in terms of the treatment of nulls with respect to ordering. But let me show you something you can do with Oracle. Oracle has a nice little feature here where you can extend the order by clause to include this expression that says where you want the nulls, either first or last. So with Oracle, I'm going to say, let's select, say everything from null tab, order by, say col A, put the nulls last, which is what it's going to do anyway. That's the default. What did I do? I forgot the S in nulls. So I want to just put one of them, I want to put all of them. So that's the default behavior, but we can make it explicit. So that doesn't add any value because we already know that's where they're going to go if you don't say anything. But here's the exciting part. We could say nulls first, and now our result is the same as we would achieve with SQL Server by simply saying order by the column with the nulls in it, order by column A. Pretty neat stuff, actually. So that's kind of nice. You can get the result rendered in the same way. So it'd be nice, I think, if all databases supported this clause in the order by, but I don't think you're going to see it in all of them. Oracle does have it. So that's a nice little feature. Okay, now, on our next slide, we say, how do you test for nulls? We already said if you say col A equal col B, and both col A and col B contain a null value, the two nulls are not going to be considered equal, and you're not going to find them. And likewise, if you say col A not equal to col B, then the two nulls are not going to be considered unequal. So how do you test? Well, I had mentioned at the start of the video that the presence of nulls affects both semantics, the kind of the meaning of the data and the meaning of the query, and syntax, the structure or the grammar of the language. So instead of saying where col A equals, and it turns out there's a special keyword called NULL, which is a way of introducing a literal that says, hey, this is the null value. Just like you can say col A equals 0, col A equals 30, you can say col A equals NULL. NULL is not in quotes, but it's kind of a reserved word or keyword that is a way of introducing null as a literal value for purposes of comparison. But if we simply say col A equal null, that's not going to work. That's the same as col A equal col B. We have to change the syntax and say col A is null. So let's select all of the rows from null tab. And we see we got the 11 rows. Now let's change the query, select all the rows from null tab that satisfy the condition of col A is null, And notice we get 6 rows, and look at what's in column A. Only null values. Similarly, we can exclude the nulls by saying select where col A is not null, and now we get all of the non-null values. But however, if our goal was to process every row in null tab, either way, we're not getting all of the rows. But we can at least be selective with respect to which rows we're dealing with, those with nulls and those without nulls. So how could we possibly process all of the rows and somehow gracefully deal with the null values? Excellent question. I'm glad you asked that. What we have is a special built-in function called coalesce. This is an ANSI standard function. This function allows us to intercept a null coming back from the database and substitute the null value, or for the null value, some other value of whatever the data type of the column is. Take a look at how we might do this here. If I go out and say, let's select the employee name and the department from the staff table, what happens is we've got Da Vinci with the null value. What if I don't want to show that null, but I want to put some other kind of eye catcher in there, not a bunch of question marks like I was using before, but maybe something like N/A because it's not applicable? Well, I can say, let's select the E name. We'll get the original department as it is, and then I'll use this coalesce function to take as its first argument the department column, the column that potentially could contain a null in a row, and rather than render the null as a null, however the front-end tool would do it, we're going to substitute and put N/A. So notice, for Da Vinci, instead of showing the null, we intercepted it into coalesce, and what came out of coalesce was this replacement value. When the value was not a null value for the first 8 rows, then this function basically just said, oh, they're not null, just show the actual value that we retrieved. So it's kind of selective substitution. Very neat little capability. And this is ANSI standard. This worked with Oracle, with DB2, with SQL Server. Now, there's another way to do this. From our earlier lecture, we introduced the case expression. And this is really pretty neat. If you go here to the next slide, case is kind of conditional logic that we can inject into our SQL statement. So it's an if-then-else type of capability. We're saying, here's a case, and here's the end of it. So there are the boundaries. When the department is not null. See, we're selecting from the staff table, so we'll get the E name and display it. We'll also get the department, because that's part of each row in the staff table. And we interrogate the department column. If department is not null, then simply display the value that's in department. That's what coalesce did. Else, if it is null, if this when clause is not true, then the else says display this. So the case expression will produce a value. It'll either produce the actual value that came into the department column, or if the when clause or condition does not evaluate to true, it'll do the else, and the output of the else will be the value that is displayed or rendered through the case expression. So let's fire this one up, because this is really pretty neat. This is an alternative to case. Oh, I'm sorry, an alternative to coalesce. Okay, case. When DEPT is not null, then display or return as the output of the expression DEPT. Else, if it is null, then return or display as output of the case expression N/A. And again, because it's a derived value, we give it a descriptive name. And you'll notice in the slide I indented. Here you've got flexibility. You don't have to indent, especially if you're lazy, like I am. And what do we get? Here is Da Vinci with N/A. so it's an alternative to using the expression. But keep in mind that coalesce is ANSI standard. Okay? So you've got a couple of ways to kind of intercept null values and deal with them somewhat gracefully. There's one more way, but before I do that, I want to back up because I had skipped a slide. Back up here, and back on slide 14, I want to bring up another point. What we're doing is saying, well, we're bound to run into a null. How are we going to deal with nulls should we encounter them? That's effectively what we've done for the entire video. What we're now looking at is, suppose these nulls are so bothersome, I don't want them to ever enter the database. Is that possible? Well, it's possible to create tables such that you can prevent nulls from ever getting into the tables, but again, you're going to have to put something in there if there's no real value that qualifies. Here's how you would do it. On a data definition statement, remember DDL is the data definition language. Create table is a data definition statement. This is how we define a table in a relational database. Create table, we give it a name, and then within parentheses, we put a description of the structure. Identify each column, giving it some name. Obviously, col 1, col 2, col 3, not very meaningful, but it serves our purpose here. And then the data type, and then we can have constraints that are defined in the column. And what we're doing in this particular example is saying col 1 is a 3-character string. It is required. You cannot skip it. You must give me 3 characters. You cannot leave it, say, vacant and put the null value in there. Nulls are not permitted. And likewise for col 2, which is an integer, you must give me a legitimate integer. And this variable length character for col 3, you must give me a character string. You cannot omit it. You could put the empty string, but you cannot put null. And then finally, primary key, dealing with entity integrity. Whatever column or columns make up the primary key, they cannot be null. That part of entity integrity. They have to be legitimate values. So here we've said col 1 and col 2 each have the not null constraint, and the primary key consists of exactly those 2 columns. So that's good. That's acceptable. So keep in mind that what this will do is this will never allow a null value to enter any of the columns in this table. But does that align with the behavior of the real world entity that this my table is actually representing? May be tricky to deal with it, but kind of keep that in mind, that it is conceptually, theoretically possible to keep nulls completely out of the database. This would be the mechanism to achieve that. Now, one more thing for dealing with nulls, should they be encountered in the database. Coalesce is an ANSI standard function, but it has not always been part of SQL. It was somewhat recently added. So initially when the products came out, vendors thought that, hey, it would be nice if we had a way to allow users of our database system to exclude nulls. Or not exclude them. They could exclude nulls with a not null constraint, but to allow nulls and then exclude them from the result set by intercepting, such as we showed with the coalesce function. But coalesce has not always been available. So originally, Oracle database used NVL and still supports it. Similar in spirit to coalesce, but this will work only with Oracle. If you type NVL as a function for DB2 or SQL Server, they're going to give you an error. DB2 uses value. Value is understood again only by DB2, but it does the same thing effectively as coalesce. Not quite, you don't have as many options, but essentially the idea. Selective replacement of null. And then finally, SQL Server supports its own proprietary function of isNull. So, there are ways of doing it that are non-standard, making the code non-portable, and there is a way, or a couple of ways of doing it where it's standard, using coalesce or using a case expression. Then the code is portable among different systems. Write it once and run it on different platforms. So what is it we've talked about? Been kind of a tough topic here because it's a little bit out there. Relational database products use this special placeholder to indicate that some real-world value somehow is missing from the entity, from the row that we have in the database. This is the null value, and it's interpreted either as value is unknown or value does not apply. And there's no way of clearly saying how to interpret it. It's simply null, and you can interpret it either way. The presence of null values in the database does have an effect on the query logic because we move from 2 values to 3 values for our logic. The syntax, we said, is also affected. It's not just a semantic concept. Instead of saying equal or equal null or not equal null, you have to say is null or is not null to explicitly pull out or identify those rows with a null value or those rows without a null value in your column. Finally, to keep nulls out of the database entirely, we have the not null constraint that we can add to a table definition. And then to deal with nulls, we mentioned there were proprietary functions, but perhaps the preferred way is to use the standard coalesce function or alternatively the case expression. So, quite a bit there. Now, the examples that I've used will be available on my accompanying website, www.timhartley.com. Simply go to the website and over where you see the menu, look for the link that says Insightful Professor. And that'll be in the menu. Click on that and a screen will come up which will show you files available that correspond or relate to the videos we've been running on the running on YouTube. So for this video, we've added the queries in a file under the label of missing information. So please let us know if you found this video useful by communicating this in the comments section. And if you've not already subscribed to our channel, please consider doing so. And this will give you kind of a heads up when we post new videos. And once again, thanks for watching.